Pencils down, people. Do not copy off the teacher. All right? Watch, learn, and then go back and do it yourself. This lesson is all about ellipses, how to graph them, how to write their equations. The ones we will do today are all ellipses with a center of 0, 0. The next lesson will involve moving these around off of the origin. All right, and here is a model for an ellipse written in standard form. So you'll notice we have this a squared and b squared that's in the bottom. A is always going to be the bigger number, and it's going to tell you whether it's horizontal. If the big number is with the x's, it'll be horizontal like this. Now that a value, right, from the a squared, that tells you how far away the vertices are to the left and to the right. Okay, so in other words, this is A. All right, A is always the long way. Okay, if I go the short way, that's B. Okay, and then the distance to the focus, that's C. So we have A, B, and right here, that would be C. Okay, so A is the long way, B is the short way, and C is the distance to the focus. So when we do these problems, you look at the equation and you get your A, B, and C. So the 64, that gives us an A value of 8. Okay, and the idea being is that 64 is our A squared, right? So that means A must be 8. Looking at the 36, B must be 6, all right, because this is 6 squared. So we have our A and our B. Now, to find the C value, we have to use this relationship right here. C squared is equal to A squared minus B squared. So similar to the Pythagorean theorem, but minus instead of plus for ellipses. C squared is equal to A squared minus B squared. So in this case, that means that C squared is going to equal A squared, which was 64, minus B squared, which is 36. Okay, so C squared is going to equal 28, and then of course we'll take the square root of both sides to get C. So if I take the square root of both sides, then C is going to equal, and let's simplify this, all right? So I'm going to the calculator, and I'm getting 2 radical 7. So look guys, now I have A, I have B, and I have C. By the way, we will need the decimal value too, so we'll just toggle that, right? So this is what happened. We did the square root of 28, and we got 2 radical 7. If I toggle that, I get 5.3. Let's round it. Okay, so let's graph this. Now, notice the bigger number is with the x. So that tells me right away that this is horizontal. All right, this ellipse is going to be stretched out in the x direction. So this 8, I'm going to go in the x direction. So I will be going over to the right 8, and I'll be going over to the left 8. Now this B, this 6 came from the y, so when I do my 6 up and down, I'll be doing that in the y direction. All right. Right there, that tells me that the ellipse is going to be looking like this. Okay? Now, the vertices are always the long way. Okay? So my vertices are -8, 0, and 8, 0. My co-vertices are the short way across. So that is 0, 6 and 0, -6. Now, my foci, or foci, the C tells me where they go. Okay, so they are 5.3 away from the center. This ellipse is going horizontally, so my foci will always go along the major axis, which is the long way. So what did I say, 5.3, so here's 5 and 0.3 would just be over a bit, and here's 5 away and then over a bit more. So those are my foci. Now, when I list my foci, I'm not going to say 5.3, 0. Oh no. I'm going to use the exact radical form. So I'm going to say 2 radical 7, 0, and negative 2 radical 7, 0. Okay, those are the exact coordinates of these 2 points. So again, don't use the 5.3 when you list them. Use the 2 radical 7. And that's it. We graphed it. We stated the information. So let's move on. Number 2. All right, in problem number 2, again, looking back at the standard form equation for an ellipse, okay, you notice that in either case, regardless of whether the big number is under the y or the x, standard form, we always have it set equal to 1. Okay, equals 1. So let's go ahead and rewrite this problem in standard form. If we know we need it to be equal to 1, then that means we're going to have to divide by 16, won't we? Okay, so those are going to cancel, but I'm not going to get 0. I'm going to get 1. Okay, now the y's are already looking normal. It's now just y squared over 16. Okay, be careful on this one though, because 16 divided by 16 is 1. So I'm just going to go ahead and put the 1 there. So it's like x squared over 1. So that tells me that a squared is 16. So you know that one of these is a squared, one of these is b squared. For ellipses, the a is always the bigger one. So 16 is my a squared, which means that a is 4, square root. And then b squared is 1, which tells me that b itself is also 1. The square root of 1 is still 1. Okay, so I still need to find c though. Maybe I'll do this off to the side. So for c, I know that c squared is equal to a squared minus b squared. That means c squared is equal to 16, right? That was my a squared, minus 1, b squared. So c squared is equal to 15, and then I will take the square root of both sides. Okay, so that gives me, so we had c squared is equal to 15, which means that c is equal to the square root of 15, which is approximately equal to 3.9 if I round up. Okay, so now I have A, B, and C. So I should be able to do this graph. Now notice that the 1 came from the x values. So that means I will go 1 in the x direction. So here's me going 1 in the x direction. So it's it's very narrow. Now the 4 came from the 16, which was with the y's. So that's why I will go 4 in the y direction. All right, it came from the y's. So I will go 4 up, and I will go 4 down. Okay, so you can see my skinny little ellipse here. Okay, so there's my skinny little ellipse. So right there, the vertices, which are always the long way, will be 0, 4, and 0, -4. The co-vertices, which are the short way, are -1, 0, and 1, 0. Now the foci, I'm going to need the C value for that. Now remember, as far as graphing them, the C value is approximately 3.9. Now the foci always go along the major axis, so it will always go the long way. So 3.9. So here's 3.9 is going to be like almost to that 4. All right, so there are my foci there, really close to the vertices. So the coordinates are 0, 3.9, but I'm not going to say 3.9. I'm going to say radical 15. Okay, and then the other one down low here is 0, negative radical 15. So when you're listing the foci, don't use the decimal form. Use a simplified radical. All right, so that's it for number 2. Let's take a look at number 3. All right, write an equation for the ellipse centered at 0, 0. Look, right there, as soon as I see that it's centered at 0, 0, that immediately tells me that I've just got x squared. All right, ellipses are always positive here. Then I've got y squared. Okay, tomorrow, when we're not at 0, 0, we're going to see things like x plus 3 squared over something, and y minus 5 squared, okay, equals 1. And that's going to tell us that the center is -3, 5, just like for parabolas and circles. But that's tomorrow. For now, we're dealing with a center of 0, 0, so that just is x squared and y squared. Our standard form always has 1 right here. Okay, so all we need is our a squared and b squared to put down here. Now, the vertex is at 0, -7. So let's graph that. 0, -7. It's right there. Okay, now this is the vertex. So by definition, by the way, there'll be one up here as well. You know, at 0, +7, that's another vertex. Okay, by definition, if it's the vertex, that means this is the long way. Okay, so this is telling me that A is 7. Okay, so we're kind of working backwards, right? So A is 7, which implies that A squared is 49. So that means one of these numbers is 49. Notice that this is in the y direction, okay? The 7 is a y value. So this 49 is going to go under the y. Okay, so all I need is the other number, the b squared. Okay, and here we go. We have a co-vertex at -1, 0. So -1, 0. So I have a co-vertex here and here. Okay, so, well, that tells me, because I'm going 1 to the left and right, that tells me that b is 1, which means that b squared is still 1. Okay, but this 1 is in the x direction, so my b squared goes with the x. And that's it. So this is the equation in standard form. Now, just to continue the graph, though, all right, the graph is going to look like this. Okay, that's about the worst graph I've ever done. All right, and just to be thorough, let's go ahead and find that c value. So remember that c squared is equal to a squared minus b squared. That means that c squared is equal to 49 minus 1. Okay, and that means that c squared is equal to 48. So if I take the square root of both sides, that gives me that c is equal to, let's see, alright, square root of 48, I'm getting 4 radical 3, which is approximately equal to 6.9. Okay, 6.9 is right up almost at the 7. Okay, we were not asked to list off the foci, so we're just graphing. So that's it. We are done. All we had to do was graph it and write an equation. So we've done that. Okay, let's move on to the final problem. This is a really short homework assignment. Okay, I know you're not complaining. Let's see here. I wanted more practice, Mr. Burton. That's what it would have sounded like if you were complaining. Write an equation of the ellipse centered at 0, 0. Once again, as soon as we see that it is 0, 0, we know it's x squared plus y squared equals 1. We know all of that just from the 0, 0. Now, we just need our a squared and our b squared. So let's see what we have. Vertex at -5, 0. Okay, so there's -5, 0. That means there's another one at 5, 0, by the way. All right, those are the vertices. Okay, so that tells me that the a value, I feel like I'll do this off to the side. A is 5, right? This was called a vertex, so that means it's definitely the long way, so I'm going to call it A. But if A is 5, that means A squared is 25. Now, this vertex is in the x direction, all right, it's horizontal. So this 25 will go underneath the x. Okay, great. What else did they tell us? Oh, they gave us the focus. The focus is at 2 radical 6 comma 0. Now look, let's go ahead and make this a decimal approximation. 2 radical 6. I knew that was going to happen. All right, so I have 2 radical 6, which is about 4.9. Okay, so I have a focus at 4.9 comma 0. All right, 4.9 is like here, okay? And that means that there'll be another one at -4.9 comma 0. So that's like right there.
Mr. Barton?
Yes. All right, when they give us the focus, they're giving us a C value. All right, so right there they're telling us, look, C is equal to 2 radical 6. Kabam. But we are going to need C squared. So we need to do 2 radical 6 squared. To the calculator. Okay, if I do 2 radical 6 squared, I would use parentheses. All right, so there's 2 radical 6 squared. 24, okay? So C squared is 24. Am I going to put that there? No, because it's got to be B squared. So how will I find B squared? Well, we will use this relationship again. C squared is equal to A squared minus B squared. Okay, so here we go. C squared is equal to A squared minus B squared. So in this case, C squared is 24. So 24 is equal to, and A squared is 25. And I need to know what B squared is. So that's what I'm solving for. So I could subtract 25 from both sides. Okay, so I get -1 is equal to negative B squared. That means 1 is equal to B squared. I'm dividing by -1 on both sides. Okay, so there it is. Now I've got my B squared. And that must be what this is. So, kabam. B squared is 1. And there's your equation. Okay? By the way, if B squared is 1, okay, that means that B is also 1. Okay, so B is 1, B squared was also 1. But this 1 tells me how far to go for the co-vertices. So I'm going to go 1 up and down. So now I could finish graphing this thing. And we're done. Okay, and that was it for number 4. Okay, the main thing was writing that equation. All right, please make sure you can do these problems by yourself. If you copied off of me at any point, all right, the test is going to come before you know it. So please go back and redo these problems on your own. All right, I hope this video was helpful to you. I will see you on the next video.